Okay, what you're looking at right now, it feels like something straight out of a movie, right? But believe it or not, this is a concept that's actually being pieced together in labs as we speak. It's called the Synth-Architect, an AI system designed to do something, well, something truly monumental. So what is it exactly?
What if you could just type a single command? Something like, build a sustainable city for 10,000 people, and then just watch an AI take it from there. Not just designing it, but actually building it from the very first foundation to the final skyscraper. Now, this isn't just about building faster. I mean, think about it. Rapidly deploying housing after a natural disaster, or building cities that are truly sustainable right from the get-go. That's the incredible promise we're going to unpack today.
So how does this whole thing actually work? Well, it breaks down into 4 really cool stages. First, you've got synthesis. That's where the AI designs the digital city. Then comes orchestration, where it conducts this huge swarm of robots. Third, execution. Pretty straightforward. The robots get to work building. And finally, and this is the really clever part, verification, where the whole system learns and self-corrects as it goes. Let's dive into each one.
All right, let's kick things off with part 1, synthesis. And we're not just talking about drawing up some blueprints here. No, this is about creating a living, intelligent master plan. Think of it as the city's digital brain, all built before a single piece of dirt is even moved. And right at the heart of this whole operation, the absolute core of it, is a concept you have to understand. It's called the digital twin. Seriously, this is the foundation for everything that comes next. So, what is it? All right, let's look at the official definition. The key words you got to focus on here are dynamic and real time. See, this isn't just some static 3D model. It's a living, breathing virtual replica. It's like having a perfect mirror of the real world that's updating itself constantly, every single second. And this right here, this shows you just what a massive leap we're talking about. A classic blueprint, a CAD model, it's static. It's a fixed drawing. It tells you what to build. But a digital twin, that's a living simulation. It doesn't just show you what to build, it shows you how to build it. And, get this, it can adapt to changes on the fly. It's literally the difference between a static photograph and a live video feed that can also predict the future. So to build this super intelligent twin, you don't just use one AI. You need a whole digital toolkit, like a team of specialists. You've got your generative AI acting like the creative architect, dreaming up the initial designs. Then you have things like knowledge graphs and machine learning. They're the logisticians and engineers, handling the rules, predicting delays. And finally, you have automated solvers. They're like the ultimate project manager, optimizing every last detail of the schedule. It's all these tools working together that creates this one single hyper-intelligent plan. All right, so we've got our living blueprint, our digital twin. Now it's time for phase 2, taking that perfect digital plan and handing it off to the crew on the ground, which in this case is a massive swarm of autonomous robots. The best way to think about the AI's role here is as a master conductor of a giant orchestra. The digital twin, that's the sheet music. And the robots, they're the musicians. The AI isn't playing every single instrument itself, no. It's directing them, making sure every bot plays its part at exactly the right moment to create this incredible symphony of construction. And we're not talking about an orchestra where everyone plays the violin. This is what's called a heterogeneous swarm, which is just a fancy way of saying you've got a ton of different specialists. You've got your big, burly heavy lifters for the steel girders. You've got 3D printers laying down concrete walls. You've got super precise assemblers for the delicate stuff. And you've got inspector bots buzzing around, making sure everything's up to code. Each one is a master of its own little job. I mean, just look at that. Trying to coordinate all those different bots is an unbelievably complex problem. In the world of robotics, they have a name for it, multi-robot task allocation, or MRTA for short. The AI literally has to take the grand plan for the city, shatter it into millions of tiny microtasks, and then figure out the perfect bot for each job based on its skills, its location, even its battery level. It's a logistics puzzle on a scale that's almost impossible to wrap your head around. Okay, so the tasks have all been handed out. Now let's zoom in. Forget the conductor for a second. Let's focus on a single musician in the orchestra. How does one of these robots actually see the chaos of a construction site, think about what to do next, and then, act? Well, it basically comes down to this really simple and powerful loop. See, think, act. First, it sees. It uses deep learning to perceive and make sense of its environment, recognizing tools, materials, other robots. Then it thinks.
It uses something called reinforcement learning to plan its next move, figuring out the safest, most efficient path. And finally, it acts, using its special tools to actually build or assemble something.
And this part is so important. These bots are not just mindless drones following some pre-programmed path. Not at all. Each one operates with a high degree of autonomy. It's making its own decisions, in real time, to navigate a construction site that is constantly changing second by second.
Okay, this brings us to the final piece of the puzzle. And honestly, this is what I think is the most revolutionary part of the whole system. This is the bit that takes it from just being cool automation and turns it into a truly intelligent, autonomous system. We're talking about the closed-loop feedback system.
So, how does it work? Well, it all starts with data, a constant stream of it. As all the robots are working, they, along with a whole network of sensors, are constantly beaming information back to the central AI. We're talking progress reports, stress measurements on the structure, you name it. And what happens to that constant flood of data? It gets fed directly back into the digital twin. The whole point is to make sure that the virtual model is a perfect, up-to-the-second mirror of what's actually happening on the physical construction site. The two worlds, virtual and physical, are now perfectly in sync.
And this is where the magic happens. The AI is constantly comparing the real-world progress, which it sees in the digital twin, against the original master plan, and if it spots any tiny difference, let's say a foundation slab is poured just a few millimeters off, it doesn't send up a red flag and wait for a human to fix it. Nope. It automatically recalculates and adjusts the plans for everything that comes after, compensating for that tiny error on the fly. It is just incredible.
There's a quote from the source material that just nails the power of this idea perfectly. It says, "This transforms the system from a rigid executor into a dynamic builder that evolves and improves with every new city it constructs." Because of that feedback loop, it's not just a dumb machine, it's a dynamic builder. It learns from its mistakes, it learns from its successes, and it literally gets smarter with every single city it builds.
So when you put it all together, the digital design, the robot orchestra, the real-time self-correction, this whole system is way more than just a new way to build. It's a massive paradigm shift. We're talking about a future where creating our physical world could become as fluid and as iterative as writing a piece of software. And that leaves us with one final, pretty mind-blowing question to ponder. When an AI can build a city with a single command, what will we even ask